curious about the things that people can do as opposed to the don'ts in order to perhaps offset macular degeneration. One of the things that I'm intrigued by are the results of Glenn Jeffrey's laboratory over at University College London. I had known Jeff for probably a decade or more, and he typically worked on animal models, but then a few years ago started publishing studies. And I believe there are now 2 published studies showing how red light exposure and near infrared light exposure done early in the day to the eye at a distance of about 2 feet for just a couple of minutes, a few times a week, could offset some of the vision loss associated with age-related macular degeneration in people older than 40. That's my understanding of these studies. And there's a theory there about enhancing function of mitochondria and photoreceptors by reducing reactive oxygen species. There's a whole mechanistic hypothesis. But my question is that the sort of protocol that produces significant enough offset of macular degeneration, like we should all be looking at red lights in the morning? Or is it still too early days in order to really conclude that?
I think the data is very compelling. The data are very compelling that this kind of red or near infrared light therapy can be at some level neuroprotective. And yes, the data suggest that kind of ramping up high functioning mitochondria is a part of that, activating neuroprotective pathways in the retina. It's actually been demonstrated in animal models and a little human data here and there, but both for macular degeneration kind of degenerative disease, but also for optic neuropathies, like glaucoma and retinal ganglion cells, the cells that carry all that visual information from the eye to the brain. They're chock full of mitochondria too. And so the idea that this could be a therapeutic approach, I think is very compelling. There are a number of studies, actually I think still ongoing today, really trying to figure out what's the right dose, how much brightness do you need, is there an optimal wavelength, how many minutes, does it matter when during the day you provide that light or how many minutes or hours? These are still very much open questions. What's the dose? What's the delivery? But it's very promising looking, and there's biological premise, and I'm excited to see where that goes because again, that's a very accessible sort of therapeutic approach that could be brought to a very broad swath of people. So yeah, I'm excited about that.
Sorry, I didn't mean to interrupt. And completely non-invasive. I should probably mention a warning, which is if people are going to decide that they're going to jump on this result and do red light exposure in the early part of the day, no matter what color a light is, if it's too bright, you can damage your eye. So I think this is why you're pointing to the fact that we need established protocols before people really start blasting their eyes with red light. And if they are going to expose themselves to red light, it shouldn't be uncomfortably bright. Do I have that correct?
Yeah, that's absolutely right. Actually, light effect, we talked about this a little bit earlier. There's actually now data also that red light, and actually, interestingly, studies using light at the other end of the visible spectrum, violet light, either of those in small daily doses can also be used to prevent progression of nearsightedness in children, in school-age children. And so I think we're really just on the cusp of really understanding the biology of how these different light therapies might be leveraged maximally to maximize our eye health, and both during development and at the other end of the spectrum as we age. So it's an exciting area, and I think this kind of phototherapy is, a very hot topic for research right now. Very hot topic.